All right. Hey, it's Mr. Shrum, and we are looking at the anatomy of the heart today. We divide the heart into four chambers: the right atrium, the left atrium, the right ventricle, and the left ventricle. Note that atrium is the singular form, and atria is the plural. So one atrium, two or three atria. Yeah. The expandable space within each atrium is called an auricle. The right atrium is the chamber of the heart that receives deoxygenated blood returning from the body. The right ventricle is the chamber of the heart that receives blood from the right atrium, which it then pumps to the lungs. Then we have the left atrium, and that is the chamber of the heart that receives oxygenated blood returning from the lungs. So you see the right atriums and right ventricle, they're dealing with deoxygenated blood returning from the body, and then it's pumped to the lungs. And then the left side, the left atrium, is the chamber of the heart that receives oxygenated blood returning from the lungs. Left ventricle receives blood from the left atrium, and then it pumps it to the body. Okay, so right to the lungs, to the left, and then pump to the rest of the body. And the heart also has four valves, and these valves make sure that blood does not flow in the wrong direction. It keeps the blood flowing correctly. And we have the two atrioventricular valves and two semilunar valves. The AV valves, I'll say that from now on, are located between the atria and the ventricles on either side of the heart. The AV valves prevent backflow of blood from the ventricles to the atria. The right AV valve is known as the tricuspid valve. It is characterized by three cusps or leaflets, thus the tri prefix. The left AV valve is known as the bicuspid or mitral valve. The bicuspid valve is characterized by two cusps, thus the bi prefix is applied. So tri for three, bi for two. You can see that here. Then we have semilunar valves, or SLV. Those are located between the ventricles and the arteries. The right SLV is the pulmonary semilunar valve. And the pulmonary SLV helps prevent backflow into the right ventricle from the pulmonary artery. So the valves keep the blood from backflowing. The left SL valve is the aortic semilunar valve. The aortic semilunar valve helps prevent backflow into the left ventricle from the aorta. When you listen to your heartbeat, it sounds like lub-dup, lub-dup. And that first sound, the lub sound, comes from the closure of the AV valve. And the second sound, the dup, is from the closure of the SLV, the semilunar valve. So those sounds are the valves making noise. The wall separating the right and left sides of the heart is called the septum. The portion separating the atria is called the atrial septum. The portion separating the ventricles is called the ventricular septum. And yeah, it's like if you've ever, the nose, they call that septum piercing, is when you get the little thing through the middle of your nose. Think of that, septum, middle, in between. There are two major veins and two major arteries that help conduct blood through the heart. You have the superior vena cava, the pulmonary artery, the pulmonary veins, and the aorta. And this picture, this diagram, kind of gives an overview of the flow. Yeah, the superior vena cava, the inferior vena cava, going into the right atrium. We have that valve, the tricuspid valve, into the right ventricle, into the pulmonary artery, to the lungs, and then from the lungs, we go to the left atrium, the mitral valve, the left ventricle, the aorta, and then out to the rest of the body. So blues coming back, reds going out. All right. The superior vena cava is the major vein that carries deoxygenated blood to the heart from the upper body. So superior, think upper, inferior, think lower body. Same thing. Inferior carries deoxygenated blood to the heart from the lower body. And you can see that in this diagram here. The pulmonary artery is a major artery that carries deoxygenated blood from the heart to the lungs, and blood enters the pulmonary artery from the right ventricle. The pulmonary artery is the only artery in the body that carries deoxygenated blood. And it's considered an artery because it carries blood away from the heart. It's carrying blood away from the heart, and yet that blood is deoxygenated. And after leaving the heart, the pulmonary artery branches into the right pulmonary artery and the left pulmonary artery, as you can see here. These branches go to the right and left lobes of the lungs. The pulmonary veins are major veins that carry oxygenated blood from the lungs to the heart. The pulmonary veins are the only veins in the body that carry oxygenated blood. However, they are considered veins because they are carrying blood to the heart. There are right and left pulmonary veins that carry blood from the right lung and the left lung, respectively. The pulmonary veins empty into the left atrium. The aorta is the major artery that carries oxygen-rich blood away from the heart to the rest of the body. Blood enters the aorta from the left ventricle and is then distributed to the rest of the body. The aorta is shaped in the form of an arch, and we call that the aortic arch. See how it's arching over the rest of the heart? Yeah, the aortic arch. And here we get another look at the path of blood circulation throughout the body. All right. And in the next lessons, you'll become more familiar with this process, and it'll become very natural for you to think of this. The vena cava, superior, inferior, into the right atrium, into the right ventricle, and into the pulmonary artery. Lungs, it's where it gets oxygenated, and then it goes to the pulmonary veins, left atrium, left ventricle, aorta via aortic SLV, and then back to the body. All right. It's important to note that the blood and oxygen supply to the heart tissues does not come from the blood flowing through the atria and ventricles. The coronary arteries supply blood and oxygen to the tissues of the heart. The heart contains an internal conduction system. The internal conduction system sends electrical impulses through the heart that results in a contraction. Conduction of the heart. This system is composed of the SA node, the pacemaker of the heart. We have the AV node, the AV bundle, the right and left bundle branches, and their Purkinje fibers. You can see those in this diagram. Conduction system. An electrocardiogram, also known as ECG or EKG, is a recording of the electrical activity of the heart. And you'll get to learn more about that in the upcoming lessons. But until next time, that has been the anatomy of the heart lesson. And if you guys have any questions, be sure to message me in Canvas. Sorry, talking a little too fast for myself. And until next time, see you guys. Good luck with everything. Have a great week. Bye-bye.